So when analyzing the Collatz conjecture, we can see four patterns. The first pattern appears in the numbers 0, 4, 8, and so on. Y equals 1/4 x, and for 0, the first iteration yields 0, and the second iteration results in 0. For the number 4, the first iteration is 2 and the second iteration is 1. For the number 8, the first iteration is 4, the second iteration is 2. The second pattern begins with the number 1 and repeats with the number 5. So we have 1 results in 4, results in 2, and finally ends up with the number 1. The iterations, the equation we use is y equals 1/4 3x plus 1. With the number 5, 5 results in 16, 16 in 8, and 8 in 4. The third pattern appears with the number 2 and repeats with the number 6, and so on. So for the number 2, we have 2, which results in 1, and then in 4, and finally in 2. The iteration is y equals 3x under 2 plus 1 under 2. The pattern repeats again with the number 6. 6 results in 3, and then in 10, and then in 5. The equation is always the same for these numbers as for the others. Finally, we have the number 3 and the number 7. The equation is y equals 3 multiplied by 3x plus 1 under 2 plus 1, and all these under 2. For the number 3, we have 3, 10, 5, 16, 8. For the number 7, we have 12, 11, 34, and 17. So for the number 1, we have for x 1, 5, 9, 13, for y 1, 4, 7, 10. This will result in an equation which is y equals 0.75x plus 0.25. Using this equation with the equation you use for the iterations, we have integer solutions which result in x equals 4n plus 1 and y equals 3n plus 1. We can see the table. For example, for n equals 0, we have x equals 1, y equals 1. For n equals 1, we have x equals 5, y equals 4, and so on. For the number 2, we use for x 2, 6, 10, 14, for y 2, 5, 8, 11. The resulting equation is y equals 0.75x plus 0.5. Using this equation with the equation we used in the iterations, we have integer solutions, which are these two equations we can see. There's a mistake I made. We can see that it's not y equals 4n plus 2, it's x equals 4n plus 2, y equals 3n plus 2. That equation is correct. So for example, for n equals 0, we have x equals 2, y equals 2. For n equals 1, we have x equals 6, y equals 5. For the number 3, you used 3, 7, 11, and 15 for x, and 8, 17, 26, and 35 for y. The equation is y equals 2.25x plus 1.25. Using this equation with the equation we use in iterations, the integer solutions will be x equals 4n plus 3 and y equals 9n plus 8. The resulting iterations will be n equals 0, x equals 3, y equals 8, n equals 1, x equals 7, equals 17. We can see that y is bigger than x, so this is a property which the number 3 and the corresponding numbers in this with this pattern will have. Finally, we have 0 and 4. And for x and y, we have for x 0, 4, 8, 12, for y 0, 1, 2, 3. The resulting equation is y equals 1 4 x. Y equals 1 4 x is the same as x equals 4 times y. And the integer solutions will be x equals 4n and y equals n. In the table, we can see that for n equals 0, x equals 0, y equals 0. For n equals 1, x equals 4, and y equals 1. For n equals 2, x equals 8, y equals 2. If we divide every time x by y, we will end up with the number 4, except for n equals 0, which is not determined. If we try to find the limit of x divided by y with n tending to infinity, we'll have the value 4. So n belongs to the natural numbers, y belongs to the natural numbers. We will end up with every natural number. Every natural number will converge to 4. So all positive integers y will converge to 4.